It's a big welcome back to Bang On in 2019. My name is Peter Banks and I wish you a very happy new year. Last year we covered irradiation and contamination in one of our videos. This part 2 in our series on radioactivity is going to look at atoms, elements and, very importantly, isotopes. I trust you find it informative. Here we go. So we start by looking at a very familiar picture, one of an atom. This is an atom of carbon, and at the centre is the nucleus. The nucleus comprises of protons. They are in red, they have a positive charge, and neutrons in blue, they have a zero charge. Whizzing round the outside, but not part of the nucleus, are electrons. They have a negative charge and counterbalance the positively charged protons in the nucleus. If we go to the periodic table of the elements, right up the top here you can see carbon has been assigned a number 6, and the reason for that is that it has 6 protons. So the atomic number in the periodic table is determined by the number of protons in the nucleus. The mass number is the total of the protons and the neutrons. And remember, whilst not part of the nucleus, the electrons are whizzing round. They're approximately 1/2000th of the weight of a proton, and they have a negative charge. We move on to this really important topic, and that is one of isotope. What you see on the screen, left and right, are 2 isotopes of the element carbon. They both have the atomic number 6, but one has 6 neutrons and carbon 14 has 6 protons plus 8 neutrons. That's 2 extra neutrons. That is an unstable radioactive isotope. If we go back to the table of elements and we go right down to the interesting corner of the table, we can see uranium. Now, some of these more obscure elements often come up in BBC Pointless. So looking at uranium, uranium occurs in an ore. That ore has to be refined down to give the pure uranium, and it is a tiny percentage. But contained within uranium there are 3 isotopes that occur in nature. Uranium-238 is 99.27 of a blob of uranium. Uranium-235 is just 0.72, and there's also a decay state called uranium-234. You can see on the screen the number of neutrons in each, which is simply the atomic number, which in this case is 92, taken from the mass number. All of the isotopes of uranium, there are 16, 13 have been generated effectively by man in various types of reactor. They are all unstable and all radioactive. And uranium-235 is fissionable. That means it can start a nuclear reaction on its own. We are going to talk about nuclear fission in a future episode. While some of that does seem quite technical, I hope it has provided some clarification. We have more topics coming up, and we will be covering uranium extraction and enrichment, half-life, decay, and we will also, of course, look in some detail at nuclear fission. So, many thanks for making the journey with me again today. Do subscribe, I really hope I've got that in the right place, or click on the blob when it appears. As I said, thank you for joining me, and we look forward to more time together this year.